Seriously, right now?
Why? What's wrong?
General, I can calculate this real-world problem using collaborative filtering like for an hour.
How long till deadline?
11 minutes and 39 seconds.
Microsoft!
Collaborative filtering is an algorithm that predicts user preferences by using the collective input of a user community. It provides personalized suggestions, making browsing more relevant and straightforward. Collaborative filtering is ideal for e-commerce, streaming services, analyzing user behavior to recommend items, even when item details are sparse or change often.
A system for different movies where we have user ratings for different films.
Our objective is to suggest movies to a certain user based on similar user ratings. To conduct this, we will have to do step-by-step simulation. First, we need to identify and initialize the data presented given. Second, we'll have to calculate their similarities by comparing our new user with preceding users using cosine similarities. After identifying their vectors, we'll have to pick the top two users that consist of the closest traits to our newbie users. Using these users' ratings, we're then going to predict the ratings for the movies that are newbie users. Finally, we're going to recommend the highest rated movies that predicted to our newbie users.
Now, here's a detailed calculation of a real-world situation that we have just given. Oh, as we've said earlier, we will have to identify the given data primarily and create a matrix, in which movie are represented by column and the users by a row. Each cell in the matrix has a user given rating to a particular movie watched by the user. The rating would range from 1 to 5, and for the unwatched movie, a null value will be placed. After the matrix or table has been set and all the data available has been provided, similarity calculation comes next. To do this, we will have to be treated with a cosine similarity formula.
There are three variables in this formula. The sum of all the elements of a sub I and b sub I is the dot product of vectors a and b. The square root of the sum of all the elements of a sub I raised to the power of 2 is the Euclidean norm or magnitude of vector a. And the square root of the sum of all the elements of b sub I raised to the power of 2 is the Euclidean norm of vector b. Using this formula, we are now going to solve for the similarity score between our target user, which is user 1, and user 2. We know that their common movies are movie A and B. Both users' ratings for movie A are 5 and 4 respectively. Their ratings for movie D are 1 and 2 respectively. We are going to solve for its dot product using these given ratings. To solve for the dot product, we have to multiply 5 by 4 and 1 by 2. The results shall be added and it would equate to a total of 22. The magnitude of vector A, we will have to solve the square root of 5 squared plus 1 squared. This would equate to the square root of 25 plus 1, and this would further equate to the square root of 26. To solve for the magnitude of vector B, we will have to solve for the square root of 4 squared plus 2 squared. It would result to the square root of 16 plus 4, and this would further result to the square root of 20. After finding these three variables, we can now solve for the cosine similarity. 22 over square root of 26 times square root of 20. This would equate to 22 over square root of 520. The square root of 520 is 22.8. So therefore, 22 over 22.8. The final result would be 0.965. Now we know that the cosine similarity between user 1 and user 2 is 0.965. We will have to do the same process for the other users with our target user. After solving for the similarity scores, here are the results. User 1 and user 2 got a 0.965, we already mentioned that. User 1 and user 3 got a similarity score of 0.949. User 1 and user 4 got a similarity score of 0.614. And user 1 and user 5 got a similarity score of 1.0.
And now, we can finally deduce the top 2 neighbors of user number 1. These are the users with the highest similarity score along with our target user. With that criteria in mind, we can deduce and identify that the first in line will be user number 5 with a whopping score of 1.0 similarity score. Next in line will be user number 2, which has a score of 0.965. The next step is to identify the ratings for user number 1's unwatched movies by using the ratings of these neighbors. The purpose of this is to identify which movies could be recommended to user number 1. To solve this problem, we'll have to use this formula.
This formula contains 3 variables. First, I represents each of the neighboring users. Similarity UI represents the similarity product of target user U and neighboring user I. And RIM is the movie rating given by user I to a certain movie M. Its numerator portion solves for the total of the product of the similarity scores and ratings, and for the denominator, the total of the similarity scores. After predicting their uninhabited ratings, we found out that movie C has a predicted rating of 4.0 and movie E has a predicted rating of 2.0.
Finally, we have now all the predicted ratings for the movies that user 1 is still yet to watch. Movie C has a predicted rating of 4.0 and movie E has a predicted rating of 2.0. Therefore, the one film that we are going to recommend to user 1 is movie C due to its high predicted rating.
Now, moving on to algorithm assessment. So, the goal is to employ collaborative filtering using cosine similarity to suggest movies to a certain user based on the ratings of similar users.
Kawatan na kap. Tarong tindog, tarong tindog. Tarong tindog. Atubang sa ko, atubang. Atubang. Ay sig dili dira. Nya karon ako'y pangutan na sa imo ha. Kay kawatan man kanda ko, tubag ako. What are the 5 main processes of collaborative filtering using cosine similarity?
This undergoes 5 processes. Number 1 is data initialization. Number 2 is similarity calculation. Number 3 is neighbor selection. Number 4 is rating prediction. Number 5 is movie recommendation.
Tama, nice. Ano, ayo.
Pangisa ba ya?
Ha?
Kayo ulit ba ba?
Ako, pangisa.
One of the few strengths of this algorithm would be its simplicity, interpretability, effectiveness, and scalability.
Kanapar.
Although it does have some limitations and potential improvements, which includes handling sparse data, increased neighbor selection flexibility. Number 3 would be cold start problem, 4 is diversity and serendipity in recommendation. And lastly, we'll be evaluating metrics.
Movies can be recommended by using the collaborative filtering method based on cause and similarity. And this is fundamental. Nonetheless, there are limits to it that could be resolved by improving them with hybrid techniques, better neighbor selection algorithms, and handling sparse data in order to enhance its efficacy and user satisfaction. This will make the system more tolerant, versatile, and welcoming to broader usership base.
General, I think we failed to beat the deadline.
Well, only one man can save us now.